This is section 8.2. This is part 5. We are simplifying radicals. And now we're going to be throwing in variables. And for most people, that makes it sound so much harder, but it is actually a lot easier to do this with variables than it is to do it with numbers. Basically, we need to remember what our index is. Here, my index is an understood 2 because it's a square root. Now, we want to simplify this. This is like elementary school division in that we want to do how many times does 2 divide into 4 and what is our remainder. 2 divides into 4 2 times with a remainder of 0, correct? So this is going to tell me my new, my exponent on the outside. Since 2 goes into 4 2 times, I'm going to have a y squared. Now, inside my radical, I would have a y to the 0 power. The remainder is the power on the inside. How many times it divides in is the power on the outside. Now, since I have no remainder, I don't have a square root anymore because this is y to the 0 power is 1, the square root of 1 is 1. Multiplying by 1 doesn't change anything. So this is just y squared. And this is saying y squared times y squared is equal to y to the 4th. And that's true. We have the property from chapter 5 where we would add our exponents. So this is true. Y squared is our answer here. Okay, for this next one, I want to find the square root of 45 times c to the 14th. First of all, we have to deal with 45. So I do a quick glance at everything I've got here. I'm glancing at all my numbers, and I see 145, but I don't see a 45 proper. So I'm going to do the prime factorization of 45. 45 is divisible by 5. It gives you 9, which is 3 times 3. So the square root of 45 will be 3 times the square root of 5. Now I'm going to copy that over here, and usually when I do this, it looks kind of ugly in the beginning. I'm leaving myself some spaces. It's 3 times the square root of 5, but I haven't dealt with the c yet, so that's why I'm leaving myself some space. I will make sure it looks proper before I leave. All right, so my index here is a 2. How many times does 2 divide into 14? 2 goes into 14 7 times, so I'm going to have a c to the 7th power on the outside. Did I have any remainder? No, it went in evenly, so I do not have any c at all on the inside. This answer is 3 times c to the 7th times the square root of 5. One thing I want you to be careful about is to make sure that this 7 stays with the c. You don't want to let it drift because this could easily become the 7th root of 5. c to the 1st power, 7th root of 5. If you're not careful about how you write it, you change the entire meaning. So be super careful about that. When you have an index other than 2 here and no power here, or if you have a power here and an index of 2 here, you need to make sure that the exponent or the index stays where it belongs. Okay, so let's look at one that doesn't work out evenly. I want the square root of a to the 13th. This is an understood 2. How many times does 2 divide into 13? Well, 2 times 6 is 12, and then I'd have one remainder, right? So 2 goes into 13 6 times, so a to the 6th power on the outside, and it had a remainder of 1, so I have a to the 1st power on the inside. Now we don't normally write a first power, so this is a to the 6th times the square root of a. Or we don't have to write the dot, we just have to make sure that it looks like a square root and not a 6th root. And that would be our answer, a to the 6th square root of a. Okay, so let's look at a cube root. Here, it works basically the same way, except instead of looking for pairs when our index was 2, we're now looking for 3 of a kind. We still do prime factorization. I want a prime factorization of 54. And I do a quick glance and I don't see 54 anywhere. So prime factorization of 54. 54 is divisible by 2, which gives me 27, which is divisible by 3, giving me 9, which is 3 times 3. Now I'm looking for cube roots, so I'm looking for 3 of a kind. Here's 3 of a kind right here. It works the same way otherwise. Since I have 3 of a kind here, the 3 is going to come on the outside. I'm going to have a 2 stuck on the inside. The thing I have to remember is that it is a cube root. We cannot lose that index. So the cube root of 54 is 3 times the cube root of 2. Coming back over here, this is 3 times the cube root of 2.